Alrighty, welcome back, boys and girls. It's your main math man, Miss Shank, coming to you live from Summit Academy. In this video, working on that Unit 4 still, and working with this lesson number 5, doing some multi-step equations and being able to solve them. So in the first part, it says to think, pair, share. So try to work with your partner to solve some of these equations, and I'll do this first one. So what I'm going to do first, again, use those inverse operations to get x by itself. What I have to do, I have to get those constant terms on one side, so I'm going to subtract 5 from both sides. I could say, all right, I have on the left side, I have negative x equals 3, which just means I have to divide both sides by a negative 1 to get my value for x. So you should always end up with x equals a number. So for this one, we're going to say x equals negative 3. So make sure for these, you can pause for your turn. Again, these should be simple one-step equations. Excuse me, be able to solve them for yourself. On the next part, it says a puzzle. So it says Tyler has invented a number puzzle. He asked Claire to pick a number and then ask her to do the following. So it has these steps, and it says Claire says that she now has negative 3 as her answer. Tyler says her original number must have been positive 3. How did Tyler know that? So what we can do is we can write our inverse operations next to these steps, so that way we can work backwards. So it's almost like we're going, up like this. And so what we're going to do is I'm going to write the inverse operation. So I'm going to say it's like we are multiplying. So multiply by 6. Opposite of subtract 22 is add 22. Double the result. That's going to be divide by 2. And then opposite of subtracting 7 is add 7, and then triple the number is divide by 3. And so what you're doing is, again, in red are those inverse operations. And so what we're trying to do is now we're going to start with this result of negative 3, and I'm going to follow these steps. I'm going to do, let's say, negative 3 times, let's do in parentheses, yeah, sure. Negative 3 times positive 6 is going to be equal to negative 18. Then I have negative 18 plus 22 is going to be equal to 4. Then I have 4 divided by 2 is going to be equal to 2. I have, this is 2 plus 7 is equal to 9. And then the last step is 9 divided by 3 is equal to 3. So the original number, or what Tyler guessed, was positive 3. So notice how, we worked in the opposite direction to get our answer. So make sure you can see how we did that. So this is similar to what we're doing for each of these problems. All right, so for now, on this practice part, it says solve each of these equations and be able to show your work. And I would say this, I'd say use the space above to show your steps. So what I'm going to do is I'm going to multiply. So this is distributive property, so I'm going to do 2 times each of the terms inside the parentheses. So I'm going to say I have x, and I have positive 5. And I multiply these two together, so this is going to be 2x, and this is going to be positive 10. And what I can do is I can write that underneath of these parentheses. So I have 2x plus 10, and then I have the rest of my equation, 3x plus 1. Make sure that you're looking for those variables on both sides. Since I have variables on both sides, I have to add the opposite of the lower coefficient. So I look at the lower coefficient, I'm going to say, well, I'm going to add the opposite of positive 2 to both sides. So it's like I'm subtracting 2x from both sides. And make sure whatever you do to one side, you do to the other. So I have 10 equals x plus 1. And then what I can do is I can subtract 1 from both sides to get my answer. So I'm just going to say this is going to be equal to 9 equals x. So now, pause and your turn. So try these out. Again, make sure you're adding the opposite to both sides or dividing so that way you can get rid of those terms. So pause for your turn, try these out. Alright, so now that you got these two next ones on here, for number 2, it says this. It says Claire was solving an equation, but when she checked her answer, she saw her solution was incorrect. She knows she made a mistake, but she can't find it. Where is Claire's mistake, and what is the solution? Alright, so Claire knows that she made a mistake, but she can't find it, and we're trying to figure out where the mistake is. So make sure, again, always too, that you're remembering that this first line is the original equation, and we're trying to say that anything after it are those steps. So if we look at the first step, we can say, well, she multiplied each term by 12, and on the right side, she multiplied each term by -1. And so I'm going to say, well, here's the mistake. It's in 2 parts. So let me kind of select it. I'm going to say right here is a mistake, and right here is a mistake. So I'm going to say right here is the, let's say mistake in step 1. And what you can do is you can say it like this. You can say, let's do green. Let's say it should be. Let's write a new line. When she multiplied incorrectly, so it should be, instead of 72, it should be 60. So I'm going to say 60 plus 24y equals, on the right side, we have 4y minus 5, and then the other mistake is it should, since it's -1 times -9, it should be positive 9y. Now we can take from these steps and solve this equation. So if we have combined like terms on one side, so I have 4y and 9y is 13y, the rest of the problem stays the same. So 13y minus 5 on the right side, and on the left side I just have 60 plus 24y. Make sure that's a y. There we go. Make sure you use those inverse operations. Since I have variables on both sides, I have to subtract or get rid of the lower coefficient. So I'm going to subtract 13y from both sides. So now I'm going to say I have 60 plus 11y equals -5. Get those constants, I should say, get those constants on one side, so I need to subtract 60 from both sides. So now I can say this is going to be equal to, fix that a little bit more. There we go. I'm going to say I have 11y equals -65. And the last step is always divide by that coefficient. So I'm going to divide both sides by 11. And I'm going to say that I have y equals -65 over 11. You can change that into a decimal if you want, or you can just leave it as a fraction. Either way, the answer is correct. So make sure you're following those inverse operations to get your variable by itself. On the back, I'm going to break this apart one step at a time, that way, or one problem at a time, that way I can have enough space. So on number 3, it says solve each equation and check your solution, which I'll show you how to do in just a second. So it says I have 1/9 times those parentheses, and I have equals 1/3 times those parentheses. What I'm going to actually do first is I'm going to multiply both sides by 9. The reason why I'm doing that is because I kind of want to get rid of these fractions because it makes it a little bit more difficult. So I should have something like this. I'm going to multiply, do it like this. I'm going to multiply both sides by 9. Because whatever I do to one side, I have to do to the other. So what I have underneath, I'm going to say I have 2x minus 16 because it gets rid of the 1/9. On the right side, I have 3 times 2x plus 4. And so what I can do my distributive property on the side here. I have your nice little box. So I'm going to say 3 times 2x and 3 times positive 4. So I'm going to have 6x plus 12. So underneath of it, I can write 2x minus 16 equals 6x plus 12. So make sure you're multiplying each term inside the parentheses by the outside amount. Now we can say, all right, well, which one's the lower coefficient? Since I have variables on both sides, I have a 2x and I have a 6x. I'm going to say, well, I can get rid of that 2x by subtracting it. So subtract 2x from both sides. And let's move this up a little bit. There we go. So I have negative 16 equals 4x plus 12. And I can say I need to get my constants on the other side. So I subtract 12 from both sides. And so now I can say I have negative 28 equals 4x. Last step, divide both sides by that coefficient. So divide both sides by 4 to get your answer. I'm going to say this is going to be negative 7 equals x. And so now you're probably wondering, how do I check my answer? So I'm going to say this. I'm going to say check by graphing. So what I'm going to do is I'm going to pick one side of my equation, type it in exactly as it looks. So if I type in this one side, I'm going to type in the other side. So I'm going to do, say in purple, type in this other side of your equation, the original equation. So let me write these steps out. So let's say it like this. So let me pull up Desmos. There it is. And so what I'm going to do is I'm going to type in one side of my equation, hit enter, and type in a new line and see where they cross. So let me fix this so that way it's reversed. And let's say, okay, I have my first equation, type in exactly as it looks. So I have 1 divided by 9 times 2x minus 16. And my other equation is 1/3 times 2x plus 4. And if you notice I have two different lines. Let me kind of match up on my graph what we have. So we had an orange, so let's do orange instead. So we said this is the orange line, the right side of our equation, and we had our blue or teal line is going to be the left side. So two different lines, but that's okay. We're finding where they're equal. And if you notice, hey, I notice that they cross at one point. And so if you notice also too, be careful, again, when you're talking about an ordered pair, you're talking about an x and a y value. So we said when x equals negative 7, that's where they are equal. So make sure you're plugging in, your first line, then plug in your second line, find out where they cross. That x value is going to be where they are equal. All right, so let me put that away and let me actually clear that out. go back to this. Okay. So similar steps. Be able to multiply each of these terms. So I'm going to say I have -4 times the quantity, and I have positive x and positive 2. So this is going to be -4x, and this is going to be -8. Then I also have on my right side, I have 4 times, I have 2 and -2x. So each time I'm doing this is called the distributive property. And so if you're having trouble when multiplying this, I would suggest checking out the video. I'll post a link in the description so that way you guys can check it out. So that way, if you need other examples of strictly just the distributive property, you'll have it as a resource. So I'm just multiplying each of these terms by 4. So that's going to be 8, and that's going to be -8x. Write those terms underneath. So that's going to be -4x minus 8 equals 8 minus 8x. Make sure you add the opposite to both sides. So since -8x is the lowest coefficient, I have adding the opposite to both sides. So add 8x to both sides. And so there's going to be 4x minus 8 equals 8. Two-step equation. Add the opposite to both sides. So I'm going to get the constants all to one side. So I add 8 to both sides. So I have 4x equals 16. Divide both sides by the coefficient. Divide both sides by 4. And I'm going to say x equals 4. Again, make sure you check by graphing. So I'm going to pull this up on Desmos. Let me re-enable it. All right, so let me do my first equation is exactly like it looks. So I have -4 times x plus 2. And my second equation is 4 times 2 minus 2x. So you might have to move your graph around, but that's okay because as soon as you find where they cross, we're going to say that's equal. So we're going to say they're equal at x equals 4. I can also prove this by substituting my answer back in. So let me show you what that looks like. So let me clear this out. The home button. And let me hide this. Okay. So I can also say check by graphing or by substitution. And when I say substitution, what that means is I can take my answer, I can take the answer that we found. So we said when x equals 4, these should be equal, and I can plug it back into our original equation. Wherever I have an x, I now should have a positive 4. So let's rewrite it. So let me just do this as an example. So I'm going to have -4 times, I have 4 plus 2 equals, we're saying is this equal to, and we're saying 4 times 2 minus 2 times 4. So all I did was I substituted 4 back into our original equation, and we're saying is this correct? So let's see. So this is going to be 8 negative, so 2 minus 8 times 4. This is going to be 6 times -4. We're saying is this equal to, so that's a question mark. Let's do on this side, we have this is -24. Is this equal to, so this is going to be -6 times 4, which is still negative 24. So we're going to say that this is right. And so that's why on your graph, that's why it made that ordered pair of 4 and negative 24, because that's where they meet on the coordinate plane. So you have the options of either check by graphing or check by doing substitution. Either way works out. All right. So now on the last one, it looks like this. I have a couple sets of parentheses, so make sure you do distributed property. So I'm going to do 12 times the quantity 5 plus 2x. So I'm going to be multiplying each of those terms inside the parentheses by positive 12. So I'm going to say I have 12 times 5 is going to be 60, and 12 times 2x is going to be positive 24x. I'm going to say 24x. 4x. There we go. Then on the right side, I have negative 1. So anytime you have that negative on the outside, just make sure you're thinking of it as a negative 1. So I'm going to do negative 1 times each of these terms. I have positive 6 and negative 9x. So this is very similar to the question on the front side that we did, but slightly different. So we're going to do, this is going to be negative 6, and this is going to be positive 9x. So underneath of them is where I can write. So I have 60 plus 24x equals 4x minus 6 plus 9x. So make sure you're distributing each of those terms. So now make sure you can combine like terms. So I have a 4x and a 9x. And so when I add those two together, that's 13x. I have minus 6. And then on the left side stays the same. So I have 60 plus 24x. Be able to get rid of that lower coefficient. So I have minus 13x to both sides. On the left side, I have 60 plus 11x equals negative 6. Again, just make sure you're trying to get rid of that lower coefficient. So again, that's the lower coefficient. That's why I subtracted both sides by 13x. Okay, so now I can get rid of get the constants on one side, so I need to subtract 60 from both sides. So I'm going to say I have 11x equals negative 66. And then I can say I divide both sides by that coefficient, so I divide both sides by 11 to get my answer. So I'm going to say x equals negative 6. And then on this one, I'm going to check by graphing. So let me write that out. Check by graphing. All right, so let's pull up our Desmos calculator one more time for this problem. Type in your problem exactly as it looks. So on the left side, I have 12 times 5 plus 2x in parentheses. Then on the right side, I have 4x minus, in parentheses, 6 minus 9x. So it said that I am at negative 6. So let's scroll the whole way down to notice. And as you're scrolling, notice how they get closer and closer because they're not parallel lines. So you have to find exactly where they meet. And also too, if you need help trying to find it, it should come up with a dot on that point. But I'm saying at the point x equals negative 6, both equations are equal to negative 84. So just be careful when you're looking at this point. We're saying x equals negative 6 is our answer, which is why in our work that we showed, we said that our answer is negative 6. All right. On the next one, some graphing linear equations or functions that we had. It says select all true statements about the line and its equation. And so what I'm going to actually do first is I'm going to kind of come up with this graph so that way it's a little bit easier to work with. And so what I'm going to do is I'm going to say, well, I notice that I'm going to say this, I'm going to say each box is equal to 1/4, which is the same as 0.25. So either way you write it, you can write it like that. And so what that means is, if I'm trying to come up with this my equation, I'm saying I'm going 1, 2, 3, 4 steps to the right, 1 step up, and so that's going to be my slope actually. So I'm going to say my equation for this line is going to be 1/4 x, and we have to find out where's our y-intercept. So our y-intercept is going to be on 5/4, which is the same as 1.25, which is why it's on one box above 1. And so this is helpful because when I'm looking at these choices, I can use my Desmos calculator to make the exact same window. So let me show you what I'm talking about. So let's go show you what I'm looking at. And what you can do is in the top right, where that little wrench is at, you can click on that little wrench. Again, that's how I change my screen so that way it's almost in dark mode. But what I can do is I can type in what my window is. So what I'm going to do is I'm going to say, okay, I want my x-axis to be between, let's say, negative 3.25 and positive 3.25. So that way it makes my window like that. And then I'm going to change the step, meaning each of those boxes is going to be 0.25. For my y-axis, same idea. I'm going from negative 1.5 to positive 2.5, and each step is going to be 0.25. So make sure you can kind of see how that works. Let me actually scroll in a little bit. There we go. So now we can kind of see how this works. So notice how it has those little boxes. We're going to say our function, our equation is y equals 1/4 x plus 5/4. So notice how it goes through that point, and it also is on the point of -1 and I think it's 0.75. I can get that actual value on there. But what we can do is now we can have these values. So on that first choice, it says one solution of the equation is 3, 2. So we're saying, is the point 3, 2 on the line? So let's find out. So have that label, so move your graph around. Notice how I type in that point. I can click the little label so that way it's easier to see. But I'm saying, hey, since this point is in fact on the line, I know it is a solution. So we're going to say for that first choice, we're going to say yes for this first choice. So this one's good. How about for the second one? Is the point -1, 1 on there? Well, yes, it is. It's right here. It's on the point. It's on our graph. And so we're going to say that one is included. So that one's good. What about 1, 3/2? Let's try that one out. So it has, we actually changed the color on this one. It's easier to see. Let's do a blue, maybe a white. Yeah, let's do a white. And let's say, what did we say? We said 1 and we said 3/2. Notice how it changes that fraction to decimal, still the same point, still the same value, so we're going to include that one as well. So make sure you can include C in that choice. So let me highlight that so that way we can type it in or show our work. So we're saying that one's good. It says there are 2 solutions. Well, right away I know that's false because, well, let me do in red. So make sure you're understanding any point on the line is a solution. And that means there's Again, there's infinitely many solutions. Because you have very small decimals in between those points. It's kind of like a line of ants. When those ants are moving, it's their own individual points. There can be small ants, it can be big ants, but they're still parts of the line. Which goes into that next choice. It says there are infinitely many solutions, which is exactly what I said, so that worked out. I even read that next option, so kudos to me. And then it says the equation to the line is the one we have, so that one's good, and that last choice is not good. So make sure you can use Desmos graphing calculator to your benefit for that option. And the last one, we have this. It says a participant in a 21-mile walkathon walks at a steady rate of 3 miles per hour. He thinks the relationship between the number of miles left to walk and the number of hours I already walked can be represented by a line with a slope of -3. Do you agree with his claim? So we're going to say, for this one, we're going to say yes. We're going to say the walker completes 3 miles each hour. Then we could say so 3 is subtracted for each 1 hour. And so when you're thinking of a line that slope of -3, it's saying for each, one step to the right, meaning for every 1 hour, it's subtracting 3 miles from the total amount remaining. So just a simple sentence for that response. Again, be sure to pause, rewind, replay as needed. Be sure to ask questions as they come up. And as always, super slam that subscribe button.